Okay, what I'd like to do now is I'd like to talk about the exam, and then we'll do the quiz. All right? And that way, when you're done with the quiz, you can go. You don't have to just wait and then talk about the exam. So, might be somewhat of a short day. All right. So where here, first of all, are the things about the exam you should know. Exam 2, of course, is going to be on the 17th. It will go from 1 p.m. to 3:30 p.m. I do not intend on giving you the 3.5 hours for the test. So it'll be, in some ways you can say there's going to be time constraints to this. All right. So just know that you'll have that much time to complete the exam. I will not do the 1 hour of review like we did before. I will be in my office from 9:30 in the morning till 1 o'clock. So if you want to get help before the test, come in, get help, and then we'll come up and take the test. So remember, office hours, 9:30 to 1 p.m. Juniper Hall, 111A. Okay, the material that this test will cover. (2.5) chain rule. 2.6 implicit. 2.7 related rates. That's the word problems, right? That's it for chapter 2. In chapter 3, 3.1 and 3.2 are just reviews, so we'll really start picking up in 3.3. 3.3 is derivatives, log, exponential. And to be honest, really, the chain rule section, I'm just telling you really here, chain rule is going to be there. There's a lot of chain rule in derivatives of logs and exponential. So let's see what else. For chapter 3, 3.7 is the next one. And this is your L'Hopital. And indeterminate forms. And that does it for chapter 3. Chapter 4, 4.1 is going to be max min. And then 4.2 is going to be, mean value theorem. Okay, now that's what the section, that's what the test is going to cover. You're more interested in what types of problems, right? So what I'd like to do now is maybe I can fit this in here. Might be able to do this. I'd like to tell you some problems out of each section that I would look at as a review. So for 2.5 chain rule, these may not be homework problems, okay? I'm already assuming you're going to have done the homework and looked at that. Here's some other problems that may or may not be homework. From 2.5, something like 23, 32, 35, 43, 47. From implicit differentiation, 11, 13, 12. Sorry, that's not in order. 21. 27. Related rates. Here's the way related rates is going to work, okay? For related rates, I would expect to see 4 problems. Oops. 4 problems. You choose 2. All right, so I'm going to give you 4 problems. You pick the 2 you want to do. You cannot do all 4 for bonus. All right, just pick the 2. Those are the 2 you go with, and that's it. Okay? So that gives you some flexibility in those problems. As far as what to look at, you know, look at the problems that you did for homework. Look at the problems that I assigned. I did add, 27 and 28, right, on top of the original set. But I would say, you know, anything off of page 132 and 133, all of those problems are pretty fair, I think. They'll be similar, remember? Not exactly similar. So on top of the homework problems, you can look at anything on those pages. I think you're good. 3-3. Okay, for 3-3, I like things like 41. I like 45, 46. You already did some homework there. Probably 53, 57. 64. 64 is a good one. L'Hopital, man, L'Hopital. The homework set for L'Hopital was what, 1 through 37? Was it 1 through 37 odd? Right, something like that. Yeah, just look at that. Look at that again. If you've done 1 through 37 odd, I would suggest you go do all the evens too, like if you've got time. For 1, again, I'm going to say focus on the problems 37 through 48. I only had you do the odds, right? Or I went through, let's say through 50. Again, focus on those homework problems. Mean value theorem, I never gave you an assignment, but 9 through 12. Now, what I'm not telling you in this is how many of each you're going to get, right? So with the next, maybe, hopefully we won't take too much time doing this. What I'd like to do is kind of, let me just do like one problem from each of these sections, like what I think are like good problems from each section. Does that sound like something you want to do, or do you want to take the quiz and get out of here? I don't mind. All right, we're going to do a couple of problems. So let me look at this chain rule section. y equals, I'm just picking one here, y equals cosine to the fourth sine cubed x. You're asked to find y prime. So this is a 2.5 problem. So the chain rule says here we got to start with the outside function. What's the last thing happening here? Fourth power, right? The fourth power. So we go 4 cosine what? Cubed, right? Sine cubed x, like that. So what we did was we looked at the fourth power as the first thing. What's the derivative of something to the fourth power? 4 times that to the third. Times. Now what's the next function going in? Cosine. What's the derivative of cosine? Negative sine of the junk, which again is sine cubed x. So I just took care of the cosine. Times, what's next? The cubed on the sine. So 3 sine squared x. So now I've taken care of the cubed on the sine. Then times the derivative of sine x, which is cosine x. That's it. If you clean this up, you would have negative 12 cosine cubed sine cubed x times sine cubed x times sine squared x cosine x. Now that's a pretty nasty problem, right? But if you can do a problem like that, you've demonstrated for sure that you understand the chain rule. At least the chain rule applied to composition of functions. It's not going to be, I guess I should say, they won't be worse than that on the test. I can't anticipate it being any worse. How about this one? We're in 2.6 now. Find equation tangent line to the curve y squared minus 4 equals x squared minus 5 at the point 0, negative 2. So what is it that you need to find in order to find the equation of a tangent line, you need a slope and a point, don't you? This goes back to the whole idea of y minus y1 equals m times x minus x1. We already know what? I mean, what is it that we already know in that red equation up there? What do we know? y1, x1, right? It's the 0, negative 2. The only thing we don't know is the slope m, but m is y prime, isn't it? At that point. So I need to find y prime from that equation. So I'm going to go get y prime. Anybody have any ideas of how they want to take the derivative of that? You can do product rule on left, right? You could actually multiply the y squared through and the x squared through on left and right. Either way, but we're going to do implicit differentiation though, right? That's the method we're going to employ. I like the idea of passing it through first. Oops. Although you wouldn't have to. It just makes it so we can avoid the product rule. Now my differentiation. What's the difference? What's the derivative of y to the fourth? 4y cubed y prime minus 8y times y prime equals 4x cubed minus 10x. Good. And now we need to get y prime by itself. So fortunately for us, we can just factor out y prime. And then divide. What now? Replace x with 0 and y with negative 2. Damn, that's pretty nice, isn't it? Is that going to give me 0? That's pretty boring, actually. 0, right? We get 0 over 2? Or 0 over who cares? It's not 0 on the bottom, right? Was it negative 2 cubed is negative 8 times 4? No. Yeah. So this gives me 0, doesn't it? So I should do it this way. So at 0, negative 2, we get that y prime is equal to 0. Which means now when I go to my equation, right, to come up, my answer is going to be here in green. My equation, y minus y1 equals m times x minus x1. I just get y minus negative 2 equals m, which is 0. So the whole right side is 0. Which means I get y plus 2 equals 0. Which means y equals negative 2. What type of line is this? Horizontal line going through negative 2. Questions? It would have been more interesting if y prime had been like 1/2 or something, right? Because then you'd have to multiply it through. But all the heart of the work there is demonstrated. Okay, how about this one? Same section. Find y double prime. If I tell you that x to the 7th plus x, oh sorry, not x, y to the 7th equals pi a to the 4th. Implicit differentiation. What's the derivative of x to the 7th? 7x to the 6th plus times y prime equals, careful, 0. So I'm trying to trick you here. Pi is a constant, right? A is a constant. So pi times a is a constant. A constant to the 4th power is still a constant. So derivative of constant is 0. Okay, now I want y prime, y double prime, right? So I need to take derivative again. So the best way to take derivative again is to just keep it as is. That little red line is going to be a product rule right there. My derivative of 7x to the 6th is what, 42x to the 5th plus 42y to the 5th y prime, product rule, careful, plus y double prime times 7y to the 6th equals 0. Do you see that product rule? Yeah? And now all I want you to do on the test is just get your y double prime by itself. Just move everything over and divide through and you're fine. Okay? All right, that's it for 2.6. 2.7. Just solve for, yeah, so you take the two terms on the left there with the 42s, you'd move them to the right, and then you'd divide through by 7y to the 6th. All right. Related rate. I didn't do 16 ever?
No, on the homework.
Okay. I don't mind doing that. It's one of my favorite problems. Okay, I'm going to do number 16. This is for 2.7, number 16. A spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks from the spotlight toward the building at a speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? What? It's all in meters. Okay, I'm happy about that. Meters per second is going to be my unit. A spotlight on the ground shines on a wall 12 meters away. Ground, wall. Actually, let me draw this a little smaller so I can draw. I have my instant versus my general. Now, the light on the ground, I'm going to mark it just with, let's say, a red dot. That's my light on the ground. It shines on a wall. The wall is 12 meters away from the light. So that should be the same in both problems, right? 12 meters. That shouldn't be changing. Yeah? No change. Okay. If a man 2 meters tall walks from the spotlight toward the building, so I'm going to draw a man. And again, I'm not going to get very artistic here. In fact, that's my man. It's just a head and a torso. Okay? It's my man. That man is walking toward the building at a speed of 1 meter per second. Where should I put the 1 meter per second then? In the general picture, maybe just as like an arrow, saying 1 meter per second as he moves to the right. Do you agree? Now he's also, in the instant that we snapped the picture on the instant on the left picture, he's stopped right at that instant. So I'm not going to show that he's moving. How fast is the length of his shadow? Where's his shadow? On the wall, right? So I didn't draw this earlier, but you know, the light's shining out here. Hallelujah. Is it I'm sorry. Yes, it is 1.6. 1.6 meters per second. So when the light strikes him, right, it's blocked, but over his head, it extends out, right? So his shadow is cast down along the wall. Here's his shadow, his head and his torso. And same with over here. Oops. They don't look the same, but who cares? Agreed? Now, just in case you know you're sitting there and you're like, man, my math teacher's not very good at drawing. I'm just going to prove to you, like, I could kick ass if I wanted to. Look at that. Okay? How about that? Yeah. Bring it. Let me see your stick man. Let's see how good your drawing is on your test. Help me! All right. There's a 4-year-old running after him right now with a little assault rifle. There we go. Now it's more interesting. So, what's happening to his shadow, damn it? I don't even remember what this problem's about anymore. How fast is the length of his shadow on the building decreasing? Does everyone agree that as he moves away, the shadow will get smaller? Right? Everyone can see that? So I want to know how fast his shadow's moving down the wall. Isn't that the distance from here to the ground? And it's changing. So what should I call it? X? Fine, that okay? H for height? S for shadow? Y because it's vertical, like the y-axis? It does not matter. You pick a variable, stick with it, okay? The one variable I always tell everyone to avoid is lowercase d. Because then you have dt, and it just kind of looks weird. So I'm going to go with H. I liked H. H for height. Now, in the other picture, is it H? No, because it's going to be fixed, isn't it, at the instant in time? The only thing I know is that at the instant in time, it says when he is what? 4 meters from the building. 4 meters from the building means that I'm going to actually move this guy over a little bit because that doesn't look right. The instant in question, the distance from here to here should be 4, shouldn't it? Sorry, I'm going to just erase this guy over here. Is that all right? I know you don't have an eraser. That my picture's all messed up now, but everyone agree with those two pictures? Any questions about it? What is it that we want? What is it that we're given? Go ahead. What do we want? We want dH dt. We want to know how fast that height's changing. At exactly the moment when? That he's 4 meters from the building. How do I say that, though? I mean, like every time we've done this in the past, we've always been able to say at, and then like a variable equals whatever. And right now I don't have a variable to represent the distance from him to the wall, which means that in my picture over here, I need to put in a distance from him to the wall. From him to the wall, that distance there is also changing, isn't it? And it's going to be called, how about X? Okay. So now I can come back down to what I want, and I can say I want dH dt at exactly the moment what is what? X is 4. Do you see how that worked out? My drawing I thought was good enough, but as I started to write down what I wanted and what I was given and stuff like that, I needed to add some more variables in here. What am I given, though? dr, what's r then? Are you given dx dt? X is the distance between him and the wall, right? Do you know how fast that thing is changing? 1.6 meters per second. But is it growing or shrinking? Shrinking. So I'm actually given dx dt in the problem is negative 1.6. Well, that makes sense? I think I've got everything. I know what I want. I know exactly when I want it. I know what's given. I think my pictures look okay. Yes? The X is 4, yes, because it says at the moment when he is 4 meters from the building. 8 is the distance from the light to him, right? But only at that instant. Okay, what do you need then? A formula to connect what two variables together? X and H. Now don't jump the gun here. That's not a right triangle, is it? No. So I think what I'm going to do right now is I'm going to come down here and I'm going to redraw my floor, my wall, which I know my wall never changed, right? But I've got the guy's shadow coming from the light source. I've got my man here. All right, that's what I've got. I know the distance from here to here is x. I'm talking about from here to here. I know the distance from here to here is h. I also know the total distance from here to here is 12, right? That's it. Remember, he's running right now, so I can't fix anything. I can't let x be 4 right now. Not until when? When can you let x be 4? After the derivative. But you need the equation before you can do the derivative, right? So what do we have here? Similar triangles. Similar triangles. So maybe you need a refresher on similar triangles. Let's say you have a triangle that looks like this and a triangle that looks like this. You could argue those don't even look like triangles, but I'm drawing fast. Let's say that this angle and this angle are the same. Then what can you tell me about the angle at the top right? They're both the same also, right? Because they also have a 90. What similar triangles, what it says is that if you say that this is, let's say, x, y, and z, and let's call this A, B, and C, to be similar triangles means if you have the same angles, all right, in your triangles, that the ratio of congruent sides the ratio of corresponding sides are congruent. And so what I could say is this. I could look at the hypotenuse and the hypotenuse. And I could say then z divided by c must be equal to any other side on this one divided by the other one's corresponding side. So I could say x over a. That would be true. I could do this so many different ways. I could flip it. C over z equals a over x. What's another one I could say? What's that? B over y is congruent to what? A over x. I could go all day long with this, okay? You can also do it this way, though. Watch this. I can take z and x together in a fraction. Z over x is the same as c over a. So you can use ratios on the same triangle equal to ratios on the other triangle. All right? So there's a bunch of different combinations of equations you can come up with off of similar triangles. What we need to do is convince ourselves that we have similar triangles. So do we have similar triangles here? Yes? I'll draw them right below it. I have a small triangle, and then I have a big triangle. What are the dimensions of the big triangle? 12 and h, right? Yes? How about the small one? Yeah, we need to know the distance from here to here, right? If the whole distance is 12, haven't we taken x out? So wouldn't this side be 12 minus x? Yes? And how tall is the man? 2. I forgot to label that, didn't I? Hey, look, back up here. No one told me how tall the guy was. I should have put a 2, not a 6. I should have put a 2 here, right? That was a given, right? He's not shrinking as he goes. It's okay that I left it out as long as I realize later, hey, shit, I need that information. Does everyone see that? So now I can set up a ratio any way I want. So there's no like right or wrong way to do this. Just do it. Just pick two sides and set up ratios. So someone give me, I'll go with the first one that's correct. 2 over 12 minus x is equal to h over 12. Everyone agree with that? You have to make sure that the sides correspond, right? It's the 2 divided by this one, right? And then it's the h divided by the 12. You can't do the 2 over the 12 minus x and then do the 12 over the h. Is that an equation that has both h and x in it? Yes. So this is it. This is what I've been working for, trying to get that. I'm going to have to start a fresh page. 2 over 12 minus x equals h over 2. Was it h over 2? No, h over 12. Same thing when we had that tangent problem. I'm going to go ahead and multiply, like cross multiply, so I don't have to do a quotient rule. So I get 24 equals 12h minus xh. What did I do there? Like cross multiply both sides by 12, and then both sides by 12 minus x, and distributed that h through. Actually, don't even know if I want to distribute that h through. Why would I not want to? It really doesn't matter at the end of the day, though. I mean, it would be a product rule, right, on the right, if I left it undistributed, but I'm still going to have to do product rule anyway, right, on that xh. Is it okay if I work with this? Okay, here we go. Differentiation. What's the derivative of 24? 0. What's the derivative of 12h? 12 d h d t minus. Now I'm going to have a product rule here. Remember, my product's right there, the x times the h. What's the derivative of x? Dx dt times h plus dh dt times x. How important were those parentheses there? Pretty vital, right? Pretty vital. Distribute that negative through. Let's just check that we have things. dh dt. Do I have that? That's what I want, right? Okay. dx dt. Do I have that? Yes. Do I have his height? Not his height. Not h in our picture was the height of his shadow, right? Do I know the height of his shadow? Not yet, right? I'm going to have to work to get that. Do I know dh dt? Well, we already said we're happy because that's what we want to solve for. Do I know what x is? At the moment in question, I know x is 4, right? So the only thing I need to resolve right now is what h is at the instant in time. Any questions? Because I'm going to go back to our previous page. I'm going to come back up here. Nope, previous to that. I'm going to go all the way back up to the top. Oh, well, yeah, I'll go right here. Here's our man. Here's our instant in question. And I'm going to look at the picture here on the left side. I know that my man was too high here. I know that this height over here is h, and I need to figure out what that is, right? So if I did real quick my similar triangles, what would they be at the instant in time? My big triangle is 12 and h, right? What's my small triangle? 8 and 2. Do y'all see what I'm doing here? Now I can set up my ratio. I'm going to go h over 2 is equal to, what would I have to say now? If I did h over 2 is equal to something, I'd have to do 12 over 8. So what's h then? 24 over 8? So h is 3. Y'all see how I got that? I remember when I was a Cal 1 student and we got to related rates, I sat there and I just thought to myself, like, is there like no geometry that's like off limits here? Like, these problems can call from anything. And there's no like all of this would be considered prerequisite material. It's stuff that you should have seen. Now you haven't used it in so long, but it's there somewhere, buried in the cracks of your short-term memory. It's in there somewhere, or it's on a page somewhere. So it's a little intimidating to realize how much they kind of expect you to just be able to throw out there. All right. We're almost done with this question here. So let me try and plug everything in now. I've got 0 here, 12. dH dt is what I wanted. Minus dx dt was what? Negative 1.6, wasn't it? H we just found to be 3 plus dH dt times x. What was x? 4. 0 equals 12 dH dt plus, what's 1.6 times 3? 4.8 minus 4 dH dt. I'm going to move the 4.8 to the other side. What's 12 dH dt's? Take away 4 of them. 8 of them. And divide through by 8. 0.6, negative 0.6. How would I measure that? Meters per second. Because height is measured in meters, time is in seconds. This was number 16? Okay. That good? I never did a problem like that, I don't think, right? Never in class. I might have done it on my other videos. Good one. Good problem. Good. Okay, so I'll give you 4, like I said. I'll give you 4 problems. You choose 2. What do y'all think about this? This is just a poll question. How about if, how do you feel about me making 2 of the questions just, these are just 2 questions that I would expect you can do. The other 2 are harder, but they're worth more. Like they're bonus. Or would you rather just have 4 just middle of the road problems? So vote. How many of you would like to see something bonus in there? Yeah? How about 3 normal ones and 1 hard one? Yeah? 3 normal, 1 hard? Okay. Okay, one more vote. 2 and 2. 3 and 1? Okay. I'm just going to make them all hard. Never mind. All right, 3-3. I'm going to run out of time here. 3-3. This is just derivatives with logs and stuff. Really, the thing I want you to know in 3-3, and I really like something like this. Find y prime if xy equals y to the x. Check this problem out. What's the derivative? What's y prime if x to the y equals y to the x? That's kind of weird, isn't it? What you have to be careful with here is that you can treat x like the independent variable. I mean, x is independent, y depends on x. So how do you take the derivative of x to the y if y depends on x? It's not just y x to the y minus 1, right? Because y is not a constant. So how do you take derivative when you have x's that appear both base and exponent? What did we do? Natural log. Take the natural log on both sides. Now what will that allow you to do to both the y and the x powers? Bring them down. Now let's take a derivative. See, I haven't done any derivative until now. Any questions, though, on what I did? What will I have to use on the left side if I'm going to do a derivative? Product. Right side? Product again. So what is the derivative of y? Y prime times ln x. Plus, what's the derivative of ln x? 1 over x. That was a quiz question. Times y. Equals. Now product rule the other side. What's the derivative of x? 1 times natural log y. So I'm just going to put natural log y. Plus, what's derivative of natural log y? Be careful. 1 over y, y prime. Good. Then times product rule, finish it off, x. Now you would get your y primes by themselves, factor out and divide. I took the yellow one to the right. I took the blue one to the left. Factor out a y prime and then divide through. Something like that. And then you could try and simplify that some more. You could maybe multiply top and bottom by y, or get a common denominator, flip the fraction over. It's good enough for now. I don't know. Did I forget to put natural log of y somewhere? Oh yeah, I completely forgot it there. Thank you. Where are you talking? It's right there the whole time. Natural log y minus y over x over that. I don't want to do any more out of this section, but I'm just sitting here looking at something like this. Y equals cosine x to the sine x. If I asked you for y prime here, that's just a problem I really would want you to be able to do. Right? Take natural log on both sides, implicit differentiation. Well, natural log on both sides, pull the sine x out, implicit differentiation. All right, what else? L'Hopital? Jeez. Here's what I'll say about L'Hopital, because I don't want to get through a bunch of these examples, all right? We did a lot of L'Hopital. Here are the things that I would guarantee expect to see on the test. You're absolutely going to see a problem where you have 0 over 0, right? And you're going to have to use L'Hopital's rule. And possibly infinity over infinity. But the likelihood of me really asking a problem like that is pretty lame, like pretty small, because that's really not a lot involved. What would be even better would be for me to do something like this. Why? Because how do you do something like that? You turn in a fraction, you drop it, and then it turns into 0 over 0, infinity over infinity, right? So I can kind of kill two birds with one stone right there, can't I? By asking you one of these instead. Or even better, if I did 1 to the infinity, problem like that, like we did today, not only do you have to do the logs to get that power out, then it turns into the 0 to the infinity, and then it goes to 0 to 0 or infinity, infinity. So to me, this is really the type of problem that if you can do those, the others should be pretty much just follow in line, right? So I'll do one or not? I mean, is that a no or yes? Yes? Limit x goes to 2 of x minus 2 to the x squared minus 4. What form do you have here? 0 to the 0. Is that bad? Yeah, because 0 wants to be 0, but anything to the 0 wants to be 1, right? So the first thing you'll do is what? After you determine it's an indeterminate form, you do what? Not yet. Can't make a fraction yet. Now, okay, you can't do natural log until you first put y equals. So we'll say y equals first. So I'm just going to say, hey, everyone, I'm going to call this limit y. Okay, now you can take natural log on both sides. And now you can pass that natural log through the limit, and that power will come down, won't it? And it will sit in front of the natural log of x minus 2. Now what form do we have? Let x go to 2. This is 0 times, what's natural log of 0 approaching? Natural log of 0. What does a natural log function do as you go close to 0? Negative infinity. Don't let that get you on the test. Everyone here by now should know natural log function looks like this. As you head towards 0, it goes to negative infinity. So 0 times negative infinity is an indeterminate form. So we pick one of them and we drop it down. I'm going to pick the x squared minus 4. Natural log x minus 2. Now when I drop it, don't I have to put it as 1 over x squared minus 4? Isn't that how I have to do it? And now I take the derivative. Well, I don't take derivative. I didn't say that right. Now I do what? Well, if you plug in 2, check it, you'll get negative infinity over infinity now. So now we can use L'Hopital's rule. So what is the derivative of natural log of x minus 2? Good. And then chain rule would say, then go inside, take derivative of what's inside, but that's just 1. So we don't need it. All over. How are you going to do the derivative of 1 over x squared minus 4? Is somebody going to put 0 over 2x on the test for the derivative of the bottom? I don't know. We'll see. What do you have to do? I mean, you could do quotient rule, couldn't you? You could say that that's x squared minus 4 to the negative 1. See, there's different ways, okay? I actually like that way. x squared minus 4 to the negative 1. I really like that because the quick derivative of this, right, derivative is going to be negative 1 x squared minus 4 to the what? Negative 2 times the derivative of what's inside, 2x. And now you can drop that x squared minus 4 back down and put the negative 1 and the 2x together and get negative 2x over x squared minus 4 squared. This is an interesting problem. I just made it up, but it's actually working out pretty cool. I'm going to flip fractions now. And I'll have the x squared minus 4 squared over negative 2x x minus 2. Does everyone agree that that's what happens when I flip that? You can get an x minus 2 to cancel. That's what I'm going to do now. But I have to first factor that, don't I? What's x squared minus 4? That's x plus 2 times x minus 2. But how many of them are there, right? It's squared, isn't it? So I have to square each of these. Then all over negative 2x times x minus 2. What a disaster. But it's about to be good. I mean, are y'all all right with this, though? What cancels out there? One of the x minus 2s, so I just have one of these now. Now take a limit. Where does the numerator go? Plug in 2. So 2 plus 2 is 4. 4 squared, 16. Uh-oh, 2 minus 2? 0 on top, but on the bottom? Negative 4. Is that a problem? Nope. The answer is 0. So natural log of y equals 0 is the answer. Well, is the result. And so now I do what on both sides? E to get y equals e to the 0, which is 1. So that limit is 1. I just skipped it, yeah. E on both. So if I was looking like for one L'Hopital rule to like cover it all, this is the type of thing, right? There's a lot involved there. The only thing I would say you didn't have to do in this problem that I would hope would happen on a test is that you might have to use L'Hopital twice. Like you do it the first time, but you still get 0 over 0, so you have to do it one more time. Okay, 4-1. And 4-2. Does anyone want to see another problem from 4-2? Or I only did one, so the mean value theorem. You all right with it or not? Do one? Okay, I'm not going to do any, I don't think I'm going to do anything else from 4-1, so this will be the last problem. Verify the mean value theorem for f of x equals 1 over x squared on the interval 1, 3. So remember, mean value theorem says that there's some point where the derivative is equal to the slope of the line connecting the two endpoints. So I would think that if I were going to take this test, that's probably a formula I'd want to have on that extra sheet if I didn't have it memorized. Right? So for us, A is 1, right? B is 3. Let me start with the right side. What's f of 3 minus f of 1 over 3 minus 1? What's f of 3? 1/9. What's f of 1? So minus 1 over 2. So I got 1/9 minus 1 over 3 minus 1 is 2. What's 1/9 minus 1? 8/9. Negative, right? I want to rewrite this over here. F prime of C equals negative 8/9 over 2. So F prime of C is negative 4/9. When you divide a fraction by 2, you basically double the denominator, right? Now I need to figure out what f prime of c is. So maybe I should take this over here real quick and do what's f prime of x? Well, that's the derivative. I need to find the derivative of x to the negative 2, don't I? Rewriting 1 over x squared, not using quotient rule. Rewriting 1 over x squared as x to negative 2. Derivative would be negative 2 x to negative 3, right? Or negative 2 over x cubed. But then replace x with c. So negative 2 over c cubed equals negative 4 over 9. Have I lost you? Y'all are all right? Cross multiply. And divide both sides by negative 1. 18 equals 4c cubed. Divide by 4. 9/2 equals c cubed. Which means c is what? Cube root of 9/2. And when you do cube root, you don't have to do plus or minus, right? It's only square root or fourth root. Anytime you take an even root, you do plus or minus. And that's it. That's all I want. Oh yeah, you have to make sure that's in the interval. It is between 1 and 3. You can do the math. That's the cube root of 4.5. How many of you don't know how to do cube roots on your calculator? Here's the way you would type that in. Most of you have graphing calculators like this. If you want to do 9/2 and take the cube root, you could do parentheses 9 over 2 raised to the parentheses 1 divided by 3. The 3 here represents the root. So if you do 9/2 raised to the 1/3, you have to have those parentheses around the 1/3 though. You should get a number between 1 and 3. Do you? 1.6 something? Yeah. All right, folks. I'm spent. How about you? Done? Okay. I'm gonna do a quiz. I'm gonna make this real nice for you. I'm gonna let you take this home. I think I'm ready to call it a day. All right? Don't get too excited now. That's what I'm doing. I'm trying to help y'all out a little bit here, okay? Let me just come up with the hardest problem I've ever given for a take-home quiz real quick. No, I'm kidding. All right. This might take me a second, so y'all just hold tight for a second. Think about how Much you love math. So I'm not going to promise you that these are going to be the easiest problems, okay? Because it is going to be a take-home quiz. Um, due Wednesday. Number 1, find absolute max min of, I got to find one thing, I'm sorry. F3. Y equals square root 1 minus x plus square root 1 plus x on the interval -1, 1. So I think the derivative might be a little bit of an issue there. Maybe not. We'll see. Okay. Just be careful when you take that derivative and set it to 0, right? Because that's what you have to do. And figure out, all that. Just be careful with your algebra there, all right? Take your time. The next one, verify the mean value theorem for the function I wish this book had better problems. Yeah. For, let's say, at y equals x sine x on the interval 0 pi over 2. That's it. You'll probably have to use decimals on that last problem. Okay, that's okay. Everyone have a good day. Careful out there, roads are going to be slick.